Assalamu alaikum students. I am a teacher from Ilm Online Academy. In today's lecture, we are going to discuss about the quadratic sequence. And as in the previous lecture, I discussed about the linear sequences with you. So for the linear sequence, I told you that that can be also termed as arithmetic sequence. Okay. And why we used to call it a linear sequence? Because when we will be finding out the first difference, so that will be having the common numbers. Okay. Like difference you can find out by subtracting the second term from the first term, and in this way you need to keep on going and finding out the differences. If you got the similar difference after finding the first difference, so that will be the linear sequence. But as today in this lecture I'm going to talk about the quadratic sequence. So quadratic sequence is the one in which the second difference will be the similar one. Like this is the first difference, okay, and this one is the second difference. Here in the first difference, you can check the terms are not similar. First difference we have got in this way, like 3 negative 1, then 7 negative 3. Each time you will pick up the next number first and then you will subtract the previous number from that. Next 13 negative 7 and 21 negative 13 as well. So all these numbers give us 2, 4, 6, 8. So these are not exactly similar numbers. So that's why we need to take one more difference that will be called as second difference. So for that, we will be going on with 4 negative 2, 6 negative 4, 8 negative 6. So in this way, we are getting the similar difference. So that's why this will let us know that this sequence is basically the quadratic sequence. Now let's discuss about the general term for the quadratic sequence. So basically, this is the general term for the quadratic sequence. This one is basically the general term for the quadratic sequence, and what this general term is basically showing us, this general term is having an square plus bn plus c. Okay, tn means the nth term. This means nth term. So a, b, and c, they will be any integer, either positive, either negative. Now we need to check that how we can find out these integers. So for finding out these integers, first of all, again, like we need to first find out the a. That is basically along with n square. As we got that the sequence is the quadratic sequence, so we will be using as n square rather than that of just one n. So along with that, a is unknown. So we need to check that how we will be finding out the a. So for finding out the a, we will be checking that what is our last common difference. Okay. And that one last common difference, you will like, as I got this common difference according to the second difference. So that's why I'm going to use this second difference with my a. Along with this, I'm going to write down the end number of my second difference. And this 2 that is being multiplied, when you will shift on the other side, it will be in the form of division. And in this way, we will be getting that what will be the value for the a. Okay, this is a way to find out the coefficient with n square. So for B and C, I will let you know further that how we will be going on. So here is one example. Let's discuss this example first and you will be more clear. So in this example, they're asking that you need to find out the nth term formula of the sequence, and the sequence has been given us. So first of all, again, finding out the first difference, second difference, and as we got the similar numbers after the first difference, after the second difference, so that's why they wrote 2a is equals to 2, and I have shown you already that how we will be getting a is equals to 1. So as a is 1, that's why they have just taken it n square directly. Like you can write 1n square, so writing 1, like you can skip this one. So this will also show like this is n square. Fine. Next, some of the steps are similar, just the way we were solving the linear sequences. Rest process is completely similar. We will be using exactly the similar sequence that they gave, and we will be making a sequence by this n square, that n square, and I told you that n will be the values like 1, 2, 3, 4, and so on. So you can check that how many values they gave us already in the sequence. Accordingly, you can use the numbers and you can take the squares of all. As you can see, they have just written over here 1, 4, 9, 16. These are the squares of the number like 1, square of 2, square of 3, square of 4, and so on. So now you need to subtract. After subtraction, again, you can see that like the common difference is like after subtracting them, they're not the similar number. So from this one, you can again find out the nth term. Okay, finding the nth term, but this will be the linear sequence now. As you have got the second difference and then similarity accordingly, you got the n square or a n square. This part you already got. Now we need to move ahead with bn. Okay, the second part, and this is basically the linear part. So you will be using this equation, using exactly the steps of the linear equation. You can find out this one, b, coefficient b. So let's start this working with exercise. So this is your exercise 1.4c, and here they are saying that you need to find the formula for nth term of each sequence. Obviously, they will not give you that the sequence is a quadratic sequence, so you will be finding out a quadratic nth term. This you need to check yourself that how you can go on with the quadratic sequence. So again, the similar thing, if you are having the second difference that is exactly similar, so that will be termed as your quadratic sequence. So let's go on with this. The first question for exercise 1.4c, the sequence that they give is 4, 7, 12, 19. So let's find out the first common difference first of all. So for finding the first common difference, we know that in 4 we need to add 3 to get 7. Next in 7 again we need to check that what we need to add to get 11. We need to add 5. Okay, 7 and 5 will be 12. Okay, next is 19 negative 12. Okay, so if from 19 I'm going to subtract, so it's giving me 7. So this is my first difference. Next, I need to check the second difference. So for second difference, 5 negative 3, it will be 2. And 7 negative 5 as well as 2. So as you got the second difference exactly similar, so this means that it's a quadratic sequence. Okay. Second difference is similar. So it's a quadratic sequence. So if it's a quadratic sequence, accordingly, the nth term will be Tn equals to an square plus bn plus c. Now, first of all, the thing is that we need to find out a. For finding out a, we know that we got this 2 as a second difference, so we will be writing 2a, and you will put that equals to 2 again, because the nth, the common number after finding out the second difference is 2 as well. So in this way, you can find out the value for the a. That is 1. So it means that here the value for the a is 1. So only you will be having n square. Okay, 1n square. So using the 1n square, we know the values of the n will be 1, 2, 3, 4, and so on. So we can find out the squares of all these numbers. So 1 square is 1, 2 square is 4, 3 square 9, 4 square 16, and so on. So first, we will be writing down the sequence that they gave us already. We have 4, 7, 12, 19. And under that, you will be writing the sequence that you made with n square. That is 1, 4, 9, 16. And now I'm going to subtract all of these numbers. So first of all, 4 negative 1, it will be 3, 7 negative 4, it's 3, 12 negative 9, 3, 19 negative 3, 16 as well as 3. So as we got exactly similar number at the end, so just you will be taking your nth term as n square plus 3. This is your quadratic sequence. Either like the linear part is missing, but still this is, or even you can say this one as a pure quadratic sequence. Okay, this is the nth term of the pure quadratic sequence. So sometimes when we are just dealing with the quadratic sequence, you might get only one term, this one, you might get only these two terms, or you might get only first and the last term, like the constant term and the square term. So accordingly, question to question, this can be having some differences. Okay. Next, we need to move towards part number 2. So let's move on. So part number 2 is basically having the sequence as 2, 8, 18, 32, and so on. Again, first of all, we are going to find out the first difference. So for finding the first difference, in 8 negative 2 will be 6, 18 negative 8 will be 10, and 32 negative 18 we need to check. Okay, 32 negative 18 is 17. So in this way, we have got the first difference. This is our first difference. Okay, next we need to check for the second difference. So 10 negative 6 will be 4. And 17 negative 10 is 7. Okay. Okay, so there might be any mistake. Yeah, here. 32 negative 18 is 14. So 14 negative 10 will be 4 again. Okay, because if the difference is not exactly similar at the end, so this can't be termed as the quadratic sequence. So as we got the similar difference now we can head towards finding out the a. First of all, as your quadratic sequence is having the nth term as an square plus bn plus c. First of all, we need to move for finding out a. So the n number that we got is 4. So we will be writing 2a because I got this 4 as my second difference, the similar number, and put that equals to 4, and similar number, and divide this by 2. And 2 times is 4. So your a is coming 2. In this way, your sequence that we need to make is be 2n square. Because I got the a as 2, so I'm going to multiply that 2 by n square like this. So 2n square. Now, n, we know that the numbers are 1, 2, 3, 4, and so on. So here, how you will be finding out the sequence with 2n square, you will be writing 2 and 1 square, then 2, 2 square, 2, 3 square, 2, and 4 square. 4 values will be enough because in this sequence as well, they gave us the 4 values. Let's simplify. 1 square is 1, and 2 1 times 2. 2 square is 4, 4 2 times is 8. 3 square is 9, 9 2 times is 18. 4 square is 16, 16 2 times is 32. So as you can check that we exactly got the similar sequence 2, 8, 18, 32, 2, 8, 18, 32. So it means that the nth term is only 2n square. Because if I'm going to find out the difference of these two sequences, I'm going to get the 0. So no need to add 0 here. Just you can write 2n square. So this is your quadratic sequence as well. Because why this is quadratic sequence again? Because here the power for the n is 2. Okay, quadratic sequence is the one where your power for the n or the indices that they gave us over here, it must be 2, not less than 2 or not more than 2. Just 2 will, if the power is there, then it's basically called the quadratic one. So this is your part number 2. Hope so this is clear. Now let's move on to the next part, and the next part is part number 3. So let's find out that what is basically the nth term of the sequence. So 0, 3, 8, and 15. So again, I'm saying that if you want to find out the if your sequence is a linear, quadratic, so you need to check it according to the common differences. Like either you are getting a common difference after the first difference, second or third one. So let's go on with this. In 0, I need to add 3 to get the number. Next number, 8 negative 3 will be 5. Okay, like we need to check that what number we need to add to get exactly the next number. And next from 15, we need to subtract 8. So it's coming 7. Okay, so this is basically the first difference. Now we need to check for the second difference of 5 negative 3 is 2 and 7 negative 5 as well is 2. This is our second difference. As we got the second difference similar, so this is a quadratic sequence, and the nth term for the quadratic sequence is an square plus bn plus c. So here if I will be checking for the a, as I got the second difference as 2, and at the second difference the 2a will be equals to 2. And a you can find as 1, so your sequence will be n square only. And accordingly, the terms will be 1, 4, 9, 16, and so on. Now I'm going to write down the sequence that they gave us. What is that? 0, 3, 8, 15. Always you need to write down the sequence that they gave us in the question first, and then you will be writing down the sequence that you will be making. So the sequence that we made is 1, 4, 9, 16, and we are going to subtract all these numbers. So 0, -1 is -1, 3, -4 is -1, 8, -9 is also -1, 15, -16 as well as -1. So the nth term of the quadratic sequence is n squared -1. So this is also the nth term of the quadratic sequence. So this was your part number 3. Let's move on with the part number 4. This one is a bit having like difference in as compared to the other in the form of decimals. We have the numbers for the sequences or the terms. So let's go on like how we are going to find out this. Exactly similar method we are going to use. There will be no any like change in the method. So part number 4 is 0.5 to 4.5, 8 and so on. Let's go on with the finding the first difference. So from 2, we need to subtract 0.5 this time. So that will be 1.5. From 4.5, we need to subtract 2 and it will be 2.5. And from 8, we need to subtract 4.5 and it's coming 3.5. So this is basically your first difference. Now we need to check for the second difference as our first difference is not similar. So 2.5 negative 1.5 is 1. And next 3.5 negative 2.5 as well as 1. So as we got the second difference similar, so it means that this is a quadratic sequence. So as this is quadratic sequence, it's better to write your nth term of the quadratic sequence. And then for finding out a, what we will do, like the nth term we got as 1, and at the second difference, so 2a will be equals to 1 this time. 2 as your second difference and 1 as the end similar number that you got. So your a is 1 by 2. If your a is 1 by 2, so your sequence according to n square will be 1 by 2n. Because whatsoever the number a you have got, because you need to write it with n square, so that's why 1 by 2n square. And for finding out the sequence according to this, at the place of n, we will be using 1, 2, 3, 4, and so on. So let's go on with this. 1 square, 1 by 2, 2 square, 1 by 2, 3 square, 1 by 2, 4 square, and so on. So first of all, 1 square is 1, and multiplying with 1 by 2 will be 1 by 2. 2 square is 4, and dividing it by 2 will be 2 times 4. 3 square is 9, so we can simply write it as 9 by 2. And 4 square is 16, so 2, 8 times 16, and so on. So this is the sequence that we got. After this, we will be writing the sequence that we were having at the start first. We will be having 0.5, 2, 4.5, 8, and so on. Under this, we are going to write down the sequence. You can write this down as well in the form of decimals, as they gave us the decimal sequence. So that is also the one possibility. Like for example, if I'm going to write this one as my sequence, so it will be 0.5, 2, 4.5, 8. So exactly similar sequence I'm getting. And if I'm going to subtract these all, I'm going to get zeros at the end. So my nth term of the quadratic sequence is just 1 by 2 n squared, just this. Because at the end, the sequence that I made with 1 by 2 n squared is exactly similar. So after finding out the difference, we are getting 0. So no need to add 0 over here. You can skip it. And your nth term for the quadratic sequence has got 1 by 2 n squared. So this is your part number 4 for 1.4c. Okay, now randomly I'm picking some questions and one by one we will be going on. Check the part number 6 here. So in part number 6, we have the sequence as -1, -4, -9, -16, and so on. So again, first of all, we are going to find out the first common difference. For finding out the first common difference, from -4, if I'm going to subtract -1, so negative will be positive. So -4 and +1 will be -3. Okay, this will be in this way, -4, -1. Okay, so -4 plus 1 will be -3. Okay, next we have -9 and +4, because negative will be again positive. -5 I've got. Next is -16, and in this we need to add 9, so that will be -7. So this is your first difference. Now finding out the next difference, -5 plus 3 will be -2, and -7 plus 5 will be -2 again. So this is your second difference. So as your second difference is similar, like either negative number, but it's second difference and it's a similar number, so like the common difference is there. So that's why this will be the quadratic sequence. So accordingly, we can write n, like the nth term of the quadratic sequence, as an square plus bn plus c. So now for finding out a, second difference is there, and that is -2. So that's why we are going to write -1. So it means that the n square, rather than writing n square, we are going to write -n square this time. So let's find out the values accordingly. We are going to have 1 square, then -2 square. Just keep your negative sign outside of the bracket, because this negative sign has nothing to do with the inside numbers. -3 square, -4 square, and so on. So -1 square will be -1, -4, -9, -16. Exactly similar numbers we got. So the nth term of the quadratic sequence is only -n square. So whenever you are getting a similar sequence again, after finding the sequence by making this an square, so you can just simply write down this part, and rest of the part you can skip. So this is your part number 6. Hope so this one is clear. Now let's move on to the next question that would be a bit different. Randomly we can pick up, and rest of the questions you can try yourself. Okay, let's go on with the 9th one. Let's see what's inside this. We have 1, 16, 15, 28, and so on. Again, finding out the first difference, 16 -1 is 15. Oh, wait, this is 6, not 16. My mistake. So 6 -1 is 5. Next, we have 15. And from 15, we need to subtract 6. And that will be 9. Next, we have 28. From this, we need to subtract 15. So it's coming 13. This is our first difference. Now we need to check the second difference. So from 9, we need to subtract 5. It will be 4. And from 13 as well, we need to subtract 9. And it's coming 4 again. So this is your second difference. So as our second difference is exactly similar, so we can write it as a quadratic sequence an square plus bn plus c. For finding out a, as our second difference is 4, so we will be writing 2a equals to 4. And for finding out a, you can shift this 2 under this, like 2 times is 4, so a is coming 2. Now we will be making a sequence by 2n square. Accordingly, at the place of n, we are going to write 1 square, then 2 into 2 square, then 2 into 3 square, then 2 into 4 square, and so on. So 1 square is 1, 1 times 2, 2 square is 4, 4 2 times is 8, 3 square 9, 9 2 times is 18, 4 square is 16, 16 2 times will be 32. So this is the sequence that we got. After this, we will be writing the sequence that they gave us at the start. We have 1, 6, 15, 28, so on. And under this, we are going to write down the sequence that we have just got. And this is basically 2, 8, 18, 32, and so on. So now I'm going to subtract all these numbers together. So first of all, 1 -2 will be -1. 6 -8, This will be also negative in the form of negative number. It will be -2. Next, 15, -18 will be -3. And from 28, if I'm going to subtract 32, it will be -4. So all these numbers are representing n, because n we have as 1, 2, 3, 4, so on. But the thing is that all the numbers are with a negative sign, so it means that these numbers can be termed as -n. So accordingly, your nth term for the quadratic sequence is 2n square, as we got this already. And from this, we need to subtract this n. So this is your nth term for the quadratic sequence. Okay, so this was the 9th part. Let's go on with the 10th one. And up till over here, we were either having the square part or this part, either square and the constant part. So in 10th one, we will be having all the 3 parts. So this will be helpful for you for understanding that how basically we are going to go on completely with the quadratic concept. So the sequence we have is 3, 9, 17, 27, so on. So first of all, we need to find out the first common difference. So 9 -3 is 6. Next, we need to find out the next difference. From 17, we need to subtract 9, it's coming 8. And from 27, we need to subtract 17, and it's coming 10. So this is your first difference. Next, 8 -6 will be 2, and 10 -8 as well is 2. So this is your second difference. So as we got the second difference similar, we can write it as this one is as quadratic sequence. So an square plus bn plus c. So as second difference I got as 2. So that's why 2a will be equals to 2 and a will be equals to 1. If a is 1, so we need to write as n square. So n square will be 1, 2 square 4, 3 square 9, 4 square 16, and so on. So now we need to write down the sequence that they give us already. We have 3, 9, 17, and 27. Under this, we are going to write down the sequence that we made. We have 1, 4, 9, 16, and I'm going to subtract all of these. So 3 -1 is 2. Next, we need to go with 9 -4, and it will be 5. Next, we need to go with 9, 17, -9 is 8. And we need to go with 27, -16. That is coming 11. So as you can check that after finding out the difference, we are not getting exactly the similar numbers at the end. So we need to get the difference again. So from here, your linear part will be started. Linear sequence part will be started. So accordingly, if I'm going to find out my differences over here, so from the second number, again, we need to subtract the first number. So 5 -2 will be 3. 8 -5 is 3. And 11 -8 as well as 3. So here, basically, this is showing us the linear sequence, and as we got the similar common difference as 3, so we can write as 3n. And now I'm going to make a sequence, linear sequence, using 3n. So at the place of n, again, I'm going to use 1, 2, 3, 4. So 3 1 times 3, 3 2 times is 6, 3 3 times is 9, 3 4 times is 12, and so on. Again, we are going to pick up the sequence that we used to make this linear part. So we have 2, 5, 8, 11, and so on. Under this, we are going to write down the sequence that they gave. We have 3, 6, 9, 12, and so on. And now we are going to subtract these all. Again, so 2 -3 is -1, -1, 8 -9, -1, 11 -12 as well as -1. So as we got exactly similar sequence, so your linear sequence is 3 and -1. Now this linear part and this quadratic part, you can combine them all, and that will be your quadratic sequence. So we have n square, positive 3n, -1. This is your quadratic sequence nth term. So hope so this one is clear. Now, students, let's move towards the next part, that is part number 11. So, in part number 11, the sequence that they give is 2, 9, 28, 65, and so on. So, again, first of all, we need to find out the first common difference. Let's find out if the common difference at the second place is similar. So 9, negative 2, first of all, we need to go at 7. Then from 28, we need to subtract 9, and it's 19. And then from 65, we need to subtract 28, and it's coming 37. This is basically your first difference. Now we need to find out the second difference. So from 19, we need to subtract 7, it's coming 12. And from 37, we need to subtract 9, and that is base 19, that is coming 18. So here you can check that your second difference as well is not similar. So if your second difference as well is not similar, so you can head towards the cubic sequence, because cubic sequence is the one where you got the third difference as the similar difference. Let's find out if it will be having the similar one. So 18 negative 12 will be 6. So this is basically the third difference that we got. So if you have gone up to the third difference, so your sequence will be termed as your the cubic sequence. So for that, whatsoever the last number you will be having, as it you have got it as third sequence, but you will not be writing it as 3a equals to 6. So for this reason, like the cubic sequence is basically having the nth term as an cube plus bn square plus cn plus d. So first of all, we need to find out a. For finding out a, you need to write as 6a equals to 6, the end number, and always for the cubic sequence, you will be using 6 with a. So for finding out a, you can divide these two. So a is basically coming 1. It means that we need to find out the sequence as 1 and cube. So 1 cube is 1, 2 cube is 8, 3 cube is 27, and 4 cube is 64, and so on. So now let's find out the difference. Your sequence that they gave us already, we have 2, 9, 28, 65. Under this, we will be writing the sequence that we just got as 1, 8, 27, and 64. And now we are going to subtract all these numbers together. So 2 negative 1, 9 negative 1, 28 negative 27, and 65 negative 64 as well as 1. So your nth term for the quadratic cubic sequence is coming as n cube positive 1. Okay. So this is basically the cubic sequence in which you have got the third term or third difference as a similar difference. Okay, so let's move on towards 13th part. So first of all, we will be checking again, like either your sequence is linear, cubic, quadratic. So we need to check the differences. We have negative 1, 6, 25, 62, and so on. Let's find out the first difference. For that, in 6, we need to add 1 because negative will be positive. So 6 and 1 will be 7. Next, from 25, we need to subtract 6. So that will be 19. And from 62, we need to subtract 25. So it's coming 37. Now going on with the second difference, from 19, we need to subtract 7. It's coming 12. And from 37, we need to subtract 19. It's coming 18. So again, your second difference is not similar. So we need to go with third difference. 18 negative 12 will be 6. So again, like for finding out the A, this sequence is basically the cubic sequence because we have gone up to the third difference. So Tn will be equals to an cube plus bn square plus cn and plus d. So for finding out the a, as your third difference is 6, so you need to write as 6a equals to 6 and your a will be 1. So the sequence that we are going to make it according to n cube. So 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, and so on. After this, we need to write down the sequence that they gave us already. Again and again, you can check that I'm using exactly the similar steps. So negative 1, 6, 25, 62, and so on. Under this, I'm going to write down the sequence that I just got 1, 8, 27, and 64. And now I'm going to subtract all of these. So -1 and -1 will be -2. 6 -8 is -2. This is as well, and this one as well. So as we got the similar number at the end, so the nth term of the quadratic sequence is, sorry, the cubic sequence is n cube -2. So this time we missed the quadratic equation part and this linear part, and only we got the answer according to a n cube and b. So hope so this one as well is clear. Now some question they used to give with the exponential sequence as well. Exponential sequence is basically the sequence in which we have the numbers in the form of power. Any power can be there. Like for example, if I have 2 power n, what does this show? That at the place of n, we need to use a number like 2 power 1, 2 power 2, 2 power 3, 2 power 4, and so on. In this way, you can get the sequence. So right now in 15th part, you can check like the numbers that they gave, they can be written the power of 3. Like we have the numbers as 3, 9, 27, 81, and so on. So how we can write them in this form of sequence? 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27, 3 power 4 is 81. So all of these are having the power as 1, 2, 3, 4. So we can write them as 3 power n. So this is your nth term of the quadratic sequence, and this is basically called the exponential sequence. So if you are getting any numbers like these or any difference you are getting exactly similar to this one, so you can term that one as an exponential sequence where your nth your n will be represented as the power of any number. So this is your exercise 1.4c. Hope so this one is clear. So see you until your next lecture.